Hi, welcome to this demo. My name is Anuraj. I am an engineering technologist with Dell. In this demo, we are going to build a generative AI digital assistant using the large language model Llama 2. And we'll be building this digital assistant on top of Red Hat OpenShift AI integrated with Dell PowerFlex and Dell Object Scale Storage Array. So for this demo, I already deployed a Red Hat OpenShift cluster and a Dell PowerFlex storage array and a Dell Object Scale Storage Array. In order to install the Red Hat OpenShift AI, first we need to configure the OpenShift image registry. So let's proceed to configure the OpenShift image registry as our initial step. We'll be integrating the OpenShift image registry with the Dell Object Scale Storage as the persistent storage for all the images. So the OpenShift cluster we built has 3 master node and 3 worker node. Now let's review the pods in the OpenShift image registry namespace. So here we can see the image registry pods are not running. So let's review the configuration of the image registry. Here we can see that the management state is removed and the storage is not yet configured. So let's configure the storage. So for that, let's go to our Object Scale console. Here go to the accounts, and in the account we already created a demo account. So let's go to the demo account, verify the users. A demo-user is already created here. Now we can review the object store created. So there is a demo-object store is already created, and in the account we can see that this object store is already connected to the demo account. Now we can go to the buckets and we can create a new bucket and provide the name as image-registry, and we'll keep all other configuration as default and create this bucket. Now the bucket is successfully created. We can use an S3 browser to connect to the object store demo account. So we can see our bucket here, and the bucket is currently empty. Next, we'll create a secret in the OpenShift image registry namespace with the secret and access key of the object scale user. So let's verify the secret is created successfully into the namespace. Now we can proceed to configure the OpenShift image registry with the object scale configuration. Now let's verify the OpenShift image registry configuration. Now here we can see that the management state changed from removed to managed, and also let's verify the storage configuration. And here we can see we successfully configured the object scale, bucket and endpoint. Now we can verify the OpenShift image registry pod status. Now we can see that the OpenShift image registry pods are in running and ready state. Next, we will integrate the Red Hat OpenShift cluster with Dell PowerFlex storage array by using the Dell CSM. And this is the Dell PowerFlex storage console. We can go to the block and review the protection domain. So we can see there is a protection domain PD01 created, and there is 4 SDS in this PowerFlex cluster. And also let's review the storage pool. So there's a storage pool created SP01, and in the host we can see our OpenShift cluster OCP02 is not yet integrated. So now we can go to the OpenShift console, and from the operator hub search for Dell CSM, and we can install the Dell CSM operator. So let's click on the Dell CSM and install. So let's wait for the operator installation to be completed. Now the operator is successfully installed. Now we can configure the CSM operator. So let's create a new project, Dell-CSM-PowerFlex, to create the PowerFlex CSM. Next, we'll create a secret with the PowerFlex configuration into this namespace. And I already created the YAML file for the PowerFlex CSM. So let's apply the PowerFlex CSM YAML file to create the CSM. Let's verify the CSM status. Now we can see the CSM is successfully installed. Also review the pod status. Also we can see all the PowerFlex CSM pods are successfully running. Now let's create a storage class to provision the PVCs from the PowerFlex storage array. So I already created the YAML file for creating the storage class. So let's review the storage class YAML file. Now apply the storage class YAML file to create the PowerFlex storage class. Now we can see the PowerFlex storage class is successfully created. Also review all the OCPC-02 worker nodes are successfully registered into the PowerFlex storage array. Now we can proceed with the installation of the Red Hat OpenShift AI. Red Hat OpenShift AI depends on certain operator to be present in the OpenShift cluster before commencing the installation of the Red Hat OpenShift AI. So let's complete the installation of all the dependent operators. First, we'll install the OpenShift Elasticsearch operator. So search for the OpenShift Elasticsearch operator in the operator hub. Then click on the operator and install this operator. So let's wait for the installation to be completed. Now the Elasticsearch operator is successfully installed. Next we can go to the operator hub again and search for the OpenShift distributed tracing platform and install this operator also. And let's wait for the operator installation to be completed. Now the OpenShift distributed tracing platform is successfully installed. Now we can install the Kiali operator. So click on the Kiali operator and install this operator. And wait for the operator to be successfully installed. Now we can install the OpenShift service mesh. So search for the OpenShift service mesh and click on the service mesh and install the OpenShift service mesh operator. And wait for the operator installation to be completed. Now the OpenShift service mesh is successfully installed. Next we'll go and install the OpenShift serverless. So click on the OpenShift serverless and install the OpenShift serverless operator into the OpenShift cluster. Now the OpenShift serverless is successfully installed into the cluster. Next again go to the OpenShift operator hub and we'll install the OpenShift pipeline operator. So install this operator and we'll wait for the OpenShift pipeline operator to be successfully installed. Now the Red Hat OpenShift pipeline operator is successfully installed. Now we don't need to configure any of this operator as we are using the automated installation. The Red Hat OpenShift AI will create all the required custom resources. Now we are good to install the OpenShift AI. So let's go to the operator hub and search for the OpenShift AI. Now select the Red Hat OpenShift AI and click on install. And we'll wait for the operator to be successfully installed. Now the Red Hat OpenShift AI operator is successfully installed into the cluster. Now let's create a data science cluster. So let's review the manifest file for the data science cluster. Now click on create to create the data science cluster and we'll wait for the status to be ready. Now the data science cluster is successfully created and the status is ready. Next, let's review the data science cluster initialization resource. Click on the resource and go to the YAML tab and review the YAML specification file here. And we can see the service mesh configuration is updated here. Now we can go to the OpenShift AI console and log into the OpenShift AI. So this is the OpenShift AI console. Now let's review the custom resources created by the OpenShift AI. So in the istio-system namespace, we can see all the service mesh resources created, and in the knative-serving namespace, we can see the serverless resources created. Now the Red Hat OpenShift AI is successfully installed. Let's proceed with the configuration of Red Hat OpenShift AI, and we'll integrate the Red Hat OpenShift AI with the Dell PowerFlex storage and the Dell ObjectScale storage. From the Red Hat OpenShift AI console, click on the data science projects and create a new data science project. Provide the name as Gen AI and click on create. Now the project is successfully created. Let's configure a cluster storage for our project. So click on the add cluster storage and provide the name as PowerFlex-PVC, as this storage will be provisioned as a PVC from our PowerFlex storage array. Now let's configure the size as 104 GB and click on add storage. Let's verify the PVC status. So go to the project Gen AI and get the PVC status. So now we can see the PVC successfully created and in a bound state. Next, we need to configure the data connection in our data science project. So for that purpose, we need to create a S3 bucket in the Dell ObjectScale storage. So let's go to the Dell ObjectScale storage console, and from the buckets, create a new bucket and provide the name as models and keep all other configuration as default. Now the bucket is successfully created. Now go to the Red Hat OpenShift AI console, and from the add data connections, create a data connection. Provide the name as ObjectScale bucket and provide the access key and the secret key of the ObjectScale user. Also provide the S3 endpoint and the name of the bucket we just created. Click on the add data connection to create the data connection. Now the data connection is successfully created. Now let's create a workbench. Click on the create workbench and provide a name for the workbench. We'll provide us workbench-llama. Then select the image and we'll select the standard data science image. And in the container size, we'll select a large size. And we'll use the existing persistent storage, the PowerFlex-PVC. And in the data connection also, we'll use the existing data connection, which is the S3 bucket in the Dell ObjectScale storage. So select the ObjectScale bucket and create the workbench. Now let's wait for this workbench to be in a started state. So now the workbench is in running state. Let's open the workbench console. So this will open a Jupyter notebook for us to work. Now we can deploy the Llama 2 model onto the Red Hat OpenShift AI. So from the Jupyter notebook, let's create a new notebook and name this notebook as Gen AI-Llama. Install all the required Python packages using the pip install command. Once all the required packages are installed, let's load the environment variables from the .env file. So I already created the .env file with all the required environment variables. Next, clone the Llama 2 model from the Hugging Face. So the cloning is going to take some time. Let's wait for the cloning to be completed. Now the cloning is completed. Let's convert the model from the Hugging Face format to the format required by the OpenShift AI. Now the model is successfully converted. Let's upload this model into the S3 bucket in Dell ObjectScale storage. Now the model is successfully uploaded to the S3 bucket. Let's use the S3 browser and browse to the bucket, and we can see the Llama model is successfully uploaded into the models bucket. Now we can deploy this model. So go to the OpenShift console and click on the deploy model and provide a name for the model and select the serving runtime and also the framework. And for time being, I'll keep the replica as 1 and select the size of the deployment. So here I'll select the custom size and configure the required CPU and memory reservations. Next, we can select the model from the object scale bucket and provide the path to the model that we need to deploy. Now click on deploy. This will start the deployment of the model onto Red Hat OpenShift AI, and we'll wait for the deployment to be completed. The model is now successfully deployed. So let's review the model deployment. And also we can get the inference endpoint from here. We can use this inference endpoint to send sample queries to the model. Now let's send a sample query, what is object scale, to this model and wait for the response. So from the response, it is very clear that at this point the model lacks the domain knowledge. Next, we need to bring our domain knowledge into this model. So now let's implement the retrieval augmented generation. And for implementing the RAG, so we will use the Redis as our vector DB and the LangChain Python library. So we'll be vector embedding all the Dell object scale documentation PDF files into the Redis vector DB. So we'll upload all those files into the Dell object scale S3 bucket first. Then from there we will actually do the vector embedding of those files into the Redis vector DB. We'll go to the OpenShift console, and from the operator hub we'll search for the Redis operator and click on the Redis operator, and we'll install this operator. So for installing the operator, let's create a new project named Redis. Now we'll wait for the installation of the operator to be completed. Now the Redis operator is successfully created. Next we need to create the Redis cluster. So go to the project Redis, and first we'll apply a custom SEC policy to be applied to the Redis pods. So now the SEC is created. Let's attach this SEC policy to the service account used by the Redis. Next, we need to create the Redis enterprise cluster. So the YAML file for creating the cluster is already created. So let's review this file. So here we can see that we are using the storage class as PowerFlex. So all the required PVCs will be provisioned from our Dell PowerFlex storage array. So let's apply this YAML file to create the Redis enterprise cluster. Now let's verify the status of the pods. And we can see all the pods are in running and ready state. And let's verify the PVC. So we can see all the PVCs are created and in bound state. So go to the OpenShift console and create a route so that we can access the Redis UI. So create route, provide a name for the route, and select the service, select the target port, and create a pass-through route. Now the route is created. Let's access the Redis UI. Now we can log into the Redis Enterprise UI, and we can see there is no database created yet. Let's review the cluster status. Now we can create a database inside this Redis cluster for embedding all of our document. So the YAML file for creating the database is already created. Then apply this YAML file to create a database inside the Redis cluster. Get the Redis UI URL from the route and access the Redis Enterprise UI. From the Redis Enterprise UI, we can see the database is successfully created. Also get the service endpoint to access the Redis database. Let's go to the Dell Object Scale console and create an S3 bucket to upload all the object scale document. So provide the name as docs and keep all the configuration as default and complete the bucket creation. Now the bucket is successfully created. Use S3 browser and upload all the documents into the docs bucket. So I already downloaded and kept the documents in my local machine. So I'll upload all this file into the S3 bucket. Now all the object scale documentation is uploaded to the docs S3 bucket. Let's verify the Redis cluster status. So we can see the Redis cluster is running successfully. Also review the Redis database. And now we can get the credential required to connect to this Redis database from the secret. Now let's proceed to do the vector embedding of all documents from the S3 bucket into this Redis database. Let's wait for the embedding to be completed. Now we have successfully completed embedding all the PDF documents from our S3 bucket into the Redis database. Now hit the same inference endpoint with the same query, what is object scale. But at this time we will send the query with a proper prompt which includes the context retrieved from a VectorDB search. So let's send this query and wait for the response. Now this time we can see that the model has responded with a very much accurate response, because now the model has access to the domain knowledge retrieved from the VectorDB. Now we can build a inference UI using the Gradio and LangChain Python library. Let's paste the Python code required to create the digital assistant UI using the LangChain and Gradio and run this code. So now we can see the local server is running on the port number 8001. So I already created a route in the OpenShift to point to the specific port. So now we can go to this URL to access the digital assistant UI. Now we can ask questions to the digital assistant about our Dell object scale storage. So let's ask the question, what is object scale? And now we can see that the model is responding with a very much accurate data from our context. Let's ask one more question, how to deploy object scale. And now we can see the response from our model. So this time also the model has responded with a very much accurate data of how can we deploy our object scale. Let's ask one more to get the step-by-step procedure of deploying the Dell object scale storage on Red Hat OpenShift cluster. So this time also we can see that the model has responded with a very good step-by-step procedure to deploy a Dell object scale storage on Red Hat OpenShift cluster. This concludes this demo. Thank you for watching.